I mime my way through it? No, I already spoke. All right, I ruined it. Okay, so I mentioned this when we were going through these problems, right? When you're factoring a trinomial, very specifically, a trinomial, a three-termed expression, right? You look at the leading, you look at the degree. The highest exponent here is 2. And I mentioned here, this degree is half of that. We can start to factor it down into binomials. When you look at this, you're like, oh, that's not quadratic, I can't do anything. What do we do now? Panic, sweat, everything. No, right? This is a trinomial. Its degree is 4. This middle term, its degree, its exponent is exactly half of that. So since this is half of this, I can factor this just like I factor one of these. Take the same approach, the exact same approach all the way through until we get to the end, and we may have to do something else, but we'll see if we have to get to that point. So, if you want to use this area model that we've been talking about, that's fine. X to the 4th goes here, negative 15 goes here. So we're looking for that perfect pair of numbers that multiply to be negative 15 and add to be negative 2. Now, talked about this as well. You want to look at both of these signs, right? If this is negative, if the constant, we call this the constant, the thing that doesn't have the variable. If the constant is negative, then those two numbers that multiply to be that, one of them has to be negative, one of them has to be positive. The sum is negative. So, of the positive and negative numbers, which one has to be bigger? The positive one or the negative one? The negative one, because the sum is negative, right? I'm throwing a lot of generic terms out there, like 1 and this and that, but I think you guys get the handle on this. So what two numbers multiply to be negative 5 and add to be negative 2? Negative 5 and positive 3. Sorry. Almost got myself there. Now, what do I attach to those two terms? Because their sum is negative 2x squared, so each one of these has to have x squared with it, right? Just like when I was doing these problems, this sum was x, so both of these had to have an x. This term was an x term, so both of these had to have an x term as well. So when we move forward, we're pulling out now the common factor here, we're pulling out the common factor here and here. So the common factor, let's do it backwards, let's go this way. What is the common factor of 3x squared and x to the 4th? X squared. What is the let's go this way. What is the common factor of negative 5x squared and x to the 4th? X squared. What is the factor of negative 15 and negative 5x squared? Negative 5. They're both negative, so I'm pulling a negative out. What is the common factor of negative 15 and 3x squared? That's the 3, right? So here I get my two binomial factors. X squared minus 5, x squared plus 3. I don't want to go crazy right now, like I don't want to take this too far, but if this was a 4, we would call this the difference of squares, and then we would factor that down into conjugates. I know we talked about that, we'll talk about it here in a little bit. I don't want to ruin the ending. All right, cut.